Compound P can be used to prepare organic compounds R and Q as shown in the flow diagram below. We are given alcohol P in reaction 1 in the presence of concentrated sulfuric acid, and then we are producing an ester. I know that is an ester because that is the functional group of esters. And then in reaction 2, the alcohol in the presence of hydrochloric acid gives me the corresponding haloalkane. Okay, so I am going to start with compound R because I know that for esters I need an alcohol as well as a carboxylic acid in order to produce the corresponding ester. So that is where I have the most information. So I'm going to write compound R in structural formulae. So this is CH3, CH2, CH2, 1, 2, 3, okay, and then I have an oxygen there, I have a carbon, and then I have CH3. This is compound R. Okay. In order for me to produce an ester, I need to have an alcohol as well as a carboxylic acid. And the simplest way to figure out what the carboxylic acid and the alcohols were, you just draw a vertical line cutting across the oxygen atom. Okay. And what you have on your left hand side will give you your corresponding alcohol, and on your right hand side will give you your corresponding carboxylic acid. Remember, the functional group of carboxylic acids looks like that, right? So it means this oxygen, it belongs to the carboxylic acids. Okay, so the corresponding alcohol must have 3 carbon atoms in its parent chain, and then I have an OH group there, so it is a primary alcohol. Okay, plus, and then I have a carboxylic acid with 2 carbon atoms, so this is going to be 1, 2. So this is the corresponding carboxylic acid. But I just want to show you something, so I'm going to invert this. So I'm going to change this and then bring. So this is the OH, and then I have 3 hydrogens there. When you are producing an ester from the alcohol and the carboxylic acid, what you do, you remove the water. So this is what you have to remove. It doesn't matter if you remove the OH from the right or if you remove the OH from the left. As long as you are left with the oxygen atom that is going to connect to the other carbon, it's fine. So this is what I'm doing. I'm removing the water. So this is me removing the water, right? And then I'm just simply going to connect these two. So as you can see, I have this is the same as that. So that is how you produce a an ester. Okay. So it means that compound P, it is an alcohol with 3 carbon atoms. So I'm going to fill in what I found. So this is carbon, 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 and then I have an OH group there. Okay, and then this is concentrated sulfuric acid, and then it gives me that ester. I'm not going to write it down. Another reaction condition that is required, you need mild heat. Okay, so now I am moving from an alcohol in the presence of hydrochloric acid. So this is going to be a substitution reaction. And then I am going to form the corresponding haloalkane. So I am just going to remove the OH and replace it with the chloride atom. And then I'm also going to form water, because this OH is going to combine with that hydrogen to produce water. Okay, let's answer the questions. In reaction 1, alcohol P reacts with another organic compound in the presence of concentrated sulfuric acid. Name the type of reaction represented by 1. When you are producing the corresponding ester, this type of reaction is known as esterification. Esterification. 4.1.2. Besides the presence of a catalyst, write down another reaction condition for reaction 1. So that is mild heat. 4.1.3. Write down the structural formula of alcohol P. So it's 1, 2, 3. That is the corresponding alcohol. 4.1.4. The IUPAC name of compound R. Let's just quickly go back here. We're still going to draw that vertical line. And then your alcohol, you name it first before the carboxylic acid when you are naming an ester. So you can see that you have 3 carbon atoms in the parent chain. So you know this is going to be prop. And then you're just going to put a YL, so it gives you the propyl. And then you move on to the carboxylic acid. So you have 2 carbon atoms. So that is an eth. So it is going to be propyl eth. Then you just put ethanoate. Just put the noate there. And then that is the name of your ester. So first, you look at the alcohol, you name the alcohol first, and then you follow by the carboxylic acid. So we have propyl ethanoate. Okay. 4.1.5. The IUPAC name of a straight chain functional isomer of compound R. Functional isomers, it means that the functional group is different. They have the same molecular formula, but the functional group is different. Okay. So how many carbon atoms do we have there? We have 1, 2, 3, 4, 5. So we have C5, and then hydrogens, that's 3, 5, 7, plus 3. So that is going to be an 11. 3, 5, 7, that's 10 actually, because it's 3 and 2, 3 and 2. So that is 10. H10. And then I have 2 oxygen atoms. So that is my molecular formula. So what you need to notice is that I have 2 oxygens there. The only functional isomer for esters is the carboxylic acids. And I know this because I know that the carboxylic acids have this right here, the functional group. So it has 2 oxygen atoms. Okay. So it must have what? 5 carbon atoms. So it's 1, 1, 2, 3, 4, 5. And then the functional group is denoted by that. So if you count your carbon atoms, you have 1, 2, 3, 4, 5. Your hydrogens, it's 3, 5, 7, 9, 10. And then you have 2 oxygen atoms. That is the functional isomer. 4.1.6. For reaction 2, write down the type of reaction that is taking place. It is a substitution reaction because we are removing the OH and replacing it with the chlorine atom. So it is a substitution. 4.1.7. The formula for the inorganic product, that is water. 4.1.8. The condensed structural formula of compound Q. 1, 2, 3. So this is Cl. But they said the condensed structural formula. So this is going to be CH3, CH2, CH2, OH. So this is going to be chlorine because we are producing that. So it is CH3, CH2, CH2, and then the chlorine. Okay. 4.2. A primary alcohol that contains 3 carbon atoms is converted to a secondary alcohol in a 2-step process as shown in the flow diagram below. A primary alcohol, it means that the carbon atom that is attached to the OH, it is attached to only 1 carbon. And they told me that I must have 3 carbon atoms. So I'm going to have another carbon. So this is the primary alcohol they are talking about. And then I need to have step 1 in which I produce compound Q, and then step 2 in which I produce a secondary alcohol. Okay, so if this undergoes an elimination reaction to produce the corresponding alkene, okay, I know that from here I can produce the corresponding secondary alcohol. Okay, so according to Markovnikov, so I'm going to need water here. Need water. And then according to Markovnikov, the hydrogen is going to go to the carbon with the most number of hydrogens. So this right here, it's the same as that, right? And then the hydrogen is going to go to the carbon atom that already has more hydrogens. This is according to Markovnikov. So the hydrogen is going to go there. And then the OH will go there. Right? And then this right here is a secondary alcohol. It is a secondary alcohol because this carbon atom that is attached to the OH group, it is attached to 2 carbon atoms. Okay. 4.2.1. The formula of reagent P. So what were we doing here? You can see that we moved from an alcohol to produce an alkene. So we were removing water because now we no longer have an OH and then we no longer have a hydrogen. So we removed water. And a good dehydrating agent would be sulfuric acid. So this must be concentrated sulfuric acid. 4.2.2. One reaction condition for the reaction in step 2. You need water. And the water must be in excess. 4.2.3. A balanced equation for the reaction in step 2 by using structural formula for the organic compounds. Okay. For Q, I know that I have an alkene, and then I need water. Can even write this like that. And then I am producing the corresponding secondary alcohol.